Hello friends, welcome to another discussion pertaining to a topic based on which questions are asked in CSAT and similar examinations. Today's topic is boats and streams, which is an extension of time and distance. That is, the concepts and the basics that we learned in time and distance are used extensively while solving questions based on boats and streams. So let us first of all have a look at the basic concepts here. Suppose this is a stream, let us say a river or a canal which is flowing here, in which there is a boat. Now stream is flowing at a speed of y kilometer per hour, whereas the speed of the boat is x kilometer per hour in still water. Now what is meant by that? Let us say that there is a pond and there is a boat in the pond. Now the water in the pond is said to be still water, and the speed of the boat in the still water is x kilometer per hour. So it is believed that in a pond or a lake, assuming that water does not flow, it is still, it is stationary, it is only the speed of the boat which is considered, and speed of water has no contribution towards increase or decrease of the net speed of this boat. Whereas when we talk about a stream, the water is flowing and it is flowing at y kilometers per hour, and the speed of boat in still water is taken as x kilometers per hour. Now, but naturally, if the boat flows in the same direction as the direction of flow of the stream, then the net speed of the movement of the boat will increase. The boat is moving at x kilometers per hour, stream is also flowing, so the net speed will become x plus y. Now in another case, if boat happens to move against the flow of the stream, that is, the stream is flowing downwards and boat is trying to move upwards against the speed of the stream. In such a case, the net speed will be the speed of the boat minus the speed of the stream, because the speed of the stream is opposing the speed of the boat. Hence, the speed of the stream is an obstruction towards the movement of the flow of the boat, which is against the stream. Therefore, the net speed or the relative speed will be the speed of the boat minus the speed of the stream, and that's exactly is the concept which will be used in boats and streams. So speed of the boat in still water is taken as x kilometers per hour and speed of stream is taken as y kilometers per hour, and if boat travels in the direction of the flow of the stream, then the speed of the boat and the stream get added. So boat speed in the direction of the flow of the stream is considered as downstream speed, denoted by d, and that is sum of the speed of the boat and speed of the stream, that is x plus y. So downstream, as the term suggests, is moving along the stream downwards, because the stream will always flow from an upper altitude to the lower altitude. So hence the term downstream. If boat travels in the direction opposite to the flow of the stream, that is against the flow of the stream, then stream's speed gets subtracted from boat's speed. So as we had discussed, boat's speed in the direction opposite to that of the flow of the stream shall become upstream speed, denoted by u, given by the difference of the two speeds, that is speed of the boat minus the speed of the stream, which is x minus y. So downstream speed is x plus y and upstream speed is x minus y. Now this is something that we need to remember while solving the questions. Now if a boat travels at d kilometers per hour along the stream, that is downstream, along the stream will always be downstream, against the stream will always be upstream, and travels at u kilometer per hour against the stream. Against the stream, that is upstream, going up, obstructed by the flow of the stream. In such a case, speed of the boat in still water, that is x, is given by d plus u by 2. Now, how did we arrive at this formula? Now, we know that downstream speed is x plus y and upstream speed is x minus y. So, if we add these two equations, we get 2x, y and minus y, they get cancelled. Now, this becomes equal to d plus u. So, from this, x becomes equal to d plus u by 2. So whenever in a question downstream speed and upstream speed are mentioned and you have to find out the speed of the boat in still water, you can make use of this formula. And speed of the stream is y equals d minus u by 2. This is how you will find out the speed of the stream. Now again, how did we arrive at this? We know downstream speed is x plus y and upstream speed is x minus y. If we subtract the second equation from the first, we get d minus u equals x and x cancels. 2y is what we get. Hence, y equals d minus u by 2. This is the expression to be used to find out the speed of the stream in case downstream and upstream speeds are given in the question. Now, let us have a look at a question here. A boat covers 24 kilometers distance along a stream in 4 hours. And it is along a stream. So, hence, this is the information pertaining to downstream speed. And the same distance against the flow of stream in 6 hours. Against would mean upstream. What will be the speed of boat in still water? That is, what is the value of x? So, downstream speed is given to us as 24 by 4. Simply employing the formula, that is, speed is equal to distance by time. D is downstream speed. 24 kilometers is the distance and 4 hours is the time. So hence the value of D comes out to be 6 kilometers per hour. Upstream speed, the distance is same, that is 26 kilometers. It is given same distance by 6 hours. That is a time given. So it works out to be 4 kilometers per hour. To find out x, we have the formula d plus u by 2, which is equal to 6 plus 4 by 2. That is 10 by 2. So the speed of the boat in still water is 5 kilometers per hour. Now let us have a look at this question. A boat covers 75 kilometers against a stream in 3 hours. So information is given to us pertaining to upstream speed, and covers 60 kilometers along the stream in 1.5 hours. That is downstream speed. What will be the speed of the boat in still water? So what is it that we need to find out? We need to find out the value of x. Now once again, upstream is given as 75 kilometers is the distance covered in 3 hours. So 75 by 3, which is 25 kilometers per hour. Downstream is given to us as 60 kilometers covered in 1.5 hours. So 60 by 1.5, which works out to be 40 kilometers per hour. And to calculate the value of x, we know the formula, that is d plus u by 2. So hence 40 plus 25 by 2, which is 65 by 2, equal to 32.5 kilometers per hour. Now here the choices are also given to us, and 32.5 kilometers per hour is given to us in choice A, which becomes the correct answer. A boat covers 8 kilometers downstream in 1 hour. So downstream is given to us as 8 kilometer in 1 hour, which is 8 kilometer per hour, and covers 2 kilometers upstream in 1 hour. So the value of u is also given, 2 kilometers in 1 hour. So the speed is 2 kilometer per hour upstream. What is the speed of the stream? Speed of the stream, we know y is equal to d minus u by 2, which is 8 minus 2 by 2, that is 6 by 2, equal to 3 kilometers per hour. Very basic question. The speed of a boat in still water is 36 kilometers per hour. So the value of x is given to us as 36 kilometers per hour. The boat covers 56 kilometers in 1 hour and 45 minutes. So first of all, 1 hour and 45 minutes equals 60 plus 45, that is 105 minutes. Now 105 by 60, if we convert it into fraction, becomes 1, 3 by 4, which again can be written as 7 by 4 hours. So 56 kilometers in 1 hour 45 minutes traveling upstream. In how much time will the boat cover the same distance while going downstream? So what is it that we need to find out? We need to find out the downstream speed. Now speed of the boat is given and upstream speed can be found out here. That is distance 56 kilometers covered in 7 by 4 hours as we calculated here on the right hand side, as you can see here, which is 56 into 4 by 7. So 7 8s are 56. It is 32 kilometer per hour. That is u. And u we know is x minus y. The difference of the two speeds, the speed of the boat and the speed of the stream. Now it is already known that the value of x is 36. It is given to us here. So hence 36 minus y becomes equal to 32. So the speed downstream will be x plus y. From here we can calculate y is 36 minus 32, that is 4 kilometer per hour, and x is already given to us. So downstream speed shall become 36 plus 4, 40 kilometers per hour. Now the question is, in how much time will the boat cover the same distance while going downstream? So downstream speed is already given to us. Distance is also mentioned, that is 56 kilometers. So the time taken will be distance by speed. Distance is 56 kilometers. Speed here is downstream speed, which is 40 kilometer per hour. So it comes here. So 56 by 40 is equal to 7 by 5. 8 7s are 56, 8 5s are 40. And 7 by 5 is 1 plus 2 by 5. 5 1s are 5, remainder 2, so 2 by 5. Now 2 by 5, if we look at it, into 60 gives us 24 minutes. So 2 by 5 hours. If you want to convert it into minutes, multiply it with 60 minutes, you get 24 minutes. So hence, the total time taken by the boat to cover this distance while traveling downstream is 1 hour and 24 minutes. Now a stream flows at 4 kilometers per hour. So the value of y is given to us as 4 kilometers per hour. A boat travels 6 kilometers downstream and then comes back to its starting point in 2 hours. So 6 kilometers is a distance which is covered while traveling downstream and again while going upstream. Same distance is covered. And the total time taken is 2 hours. So for how much time did the boat travel upstream? Now first of all, y is given to us, total time is given to us, and we know time is distance by speed. So the total time taken will be time taken to travel upstream plus time taken to travel downstream. Now total time taken shall be given by distance here happens to be the same. X minus y is the value of u and x plus y is the value of downstream. So employing this, the distance traveled upstream and downstream happens to be the same, that is 6 kilometers. Value of y is given to us, but x is unknown. So upstream we know is x minus y, so we used it here. Downstream speed is x plus y, so we used it here. And the total time is given to us as 2 hours. So we do the cross multiplication here, we get 6x plus 24 plus 6x minus 24. And x minus 4 into x plus 4 is x square minus 16. Anyhow, we take this to the RHS. So plus 24 minus 24 cancels. 6x plus 6x gives us 12x. And this anyhow works out to be x square minus 16 into 2 if we do. So 2x square and 2 into minus 16, that is minus 32. We get a quadratic equation here. Further reducing this, dividing this by 2, we get x square minus 6x minus 16 equals 0. We will factorize this as x minus 8 and x plus 2 because the product is minus 16 and the sum of the factors is minus 6. So the larger factor here has to be negative, or so as to say the factor whose absolute value is greater than the other, we will take that as negative. So hence minus 8 plus 2, so hence minus 8 plus 2 is minus 6 and minus 8 into 2 is minus 16. So this gives us the value for x to be 8 kilometers per hour. But the question is, for how much time did the boat travel upstream? Now time taken by the boat to travel upstream is given by the formula time is equal to distance by speed. Distance traveled is 6 kilometers and speed here is u, that is x minus y. So 8 minus 4, x is 8, y is 4. Take the difference between the two. So 6 by 4, which is 1.5 hours. So the time taken by the boat to travel upstream was 1.5 hours to cover the 6 kilometers, whereas while traveling downstream, it must have traveled only half an hour, because the total time taken to travel downstream and upstream is given to us here as 2 hours. Anyhow, this serves our purpose as the answer. The next question, a boat covers 30 kilometers upstream and 44 kilometers downstream in total 10 hours. So the distance covered when a boat is moving upstream against the flow of the stream, the distance is 30 kilometers, and when the boat travels downstream, that is along the flow of the current, it is covering 44 kilometers. So the distances covered here are different in the two cases, but the total time taken is given to us as 10 hours. Now the same boat traveling at the same speed covers 40 kilometers upstream and 55 kilometers downstream in total 13 hours. So there are two instances given to us. In the first instance, a boat travels 30 kilometers upstream and 44 kilometers downstream in 10 hours. And in the second instance, the same boat traveling at the same speed covers 40 kilometers upstream and 55 kilometers downstream in total 13 hours. Now, what is the speed of the boat in still water? So what we need to find out here is the value of x. Now, it is known that downstream speed is sum of x plus y. That is sum of speed of the boat in still water plus the speed of the stream. And u, that is the speed upstream, is the difference of the two speeds, x and y. Now, we know that time equals distance by speed. So, employing this formula, we know that in this case, when the boat was traveling upstream, it covered 30 kilometers. So, the time taken to travel that 30 kilometers of distance upstream must be distance by speed. And the net speed here is u, that is the upstream speed. Similarly, while traveling downstream, it has covered 44 kilometers, that is the distance, at a speed of p, which represents the downstream speed. So hence, T2 we can find out using this formula. Now, the total time taken to travel these two distances is 10 hours. So we can say this is T1, 30 by u, as we see here, and this is T2, 44 by d, time taken to travel 30 kilometers upstream plus time taken to travel 44 kilometers downstream becomes 10 hours as the total time taken to travel these two distances. So that is equal to 10. So taking LCM here, doing cross multiplication, we get 30d plus 44u equals 10 du. Now here, 30, 44 and 10. Each of these numbers is divisible by 2. So we will further reduce this to 15. 44 becomes 22 and 10 becomes 5. So that 15d plus 22u, when this 5 on the right hand side goes to the left hand side denominator, it becomes equal to du, and this we shall consider as equation 1. Now similarly, we will take the case of the second instance. 40 kilometers upstream, so time taken is 40 by u. 55 kilometers downstream, so the time taken is 55d. Now total time taken is 13 hours, so it is equal to 30. Once again, doing the cross multiplication, we get 40d plus 55u by 13 as du. This shall be our second equation. Now when we compare these two equations, the value of du is given here as well as here. We shall equate these two values, and when we do that, we get 15d plus 22u by 5, which equals 40d plus 55u by 13. As both these components are equal to du, we can equate these two components. Now 13 gets multiplied here, 5 gets multiplied here. So when we look at this step, 13 into 15, 195, 13 into 22, 286, 5 into 40, 200, and 5 into 55, 275. This is what we get. Now when we resolve this 195d and 200d, we shall get a 5d here, and 286u and 275u, we shall get 11u. So what we get here is a 5d equals 11u. Now this means 5 into x plus y equals 11 into x minus y. we shall open this equation. 5x plus 5y equals 11x minus 11y. So resolving for x, resolving for y, we get 6x equals 16y. We can further reduce it to 3x equals 8y. So now the ratio between x and y becomes clear to us. It is 8 by 3, which is given here. So x becomes 8 km per hour and y becomes 3 km per hour. Although these are ratio points, but still you can find out by using these two values in one of the equations. So let us do one thing. Take the first instance. It is 30 kilometers upstream and 44 kilometers downstream. So 30 by upstream, that is difference of x and y. So 8 minus 3 plus 44 by downstream speed, that is x plus y. So 8 plus 3. This should be equal to 10. So 8 minus 3 here works out to be 5. And 8 plus 3 here works out to be 11. 11 and 44 cancels by 4. 5 and 30 cancels by 6. So 6 plus 4 is equal to 10. It works out. Now similarly, you could have performed the check for the second instance, and that is 40 kilometers upstream. So the time taken must be 40 by 8 minus 3 plus 55 kilometers downstream. That must be 55 by 8 plus 3. Once again, this is equal to 5 and this is equal to 11. 5 and 40 cancel by 8. 11 and 55 they cancel by 5. And the sum of these two values equals 13 hours, which is given to us here. So it works out. Now the question was, what is the speed of the boat in still water? That we know here. It is 8 kilometers per hour. Now, a swimmer swims upstream for 5 minutes from point A and then swims downstream for 5 minutes to come back to point B. If the distance between the points A and B is 100 meters, then what will be the speed of the stream? Now let us say this is point A, and from here a swimmer swims for 5 minutes and reaches point C and then swims downstream for 5 minutes to come back to point B. Now the distance covered on swimming for 5 minutes upstream will be lesser because the speed of the swimmer will become less. The upstream speed will become the difference of the speed of the swimmer in still water and the speed of the stream. So when the swimmer is swimming against the current, then obviously he would be covering less distance. Whereas when swimmer swims downstream for the same period of time, that is 5 minutes, he reaches point B. Now this is point B, let us say. So obviously while swimming downstream, swimmer must be covering more distance and his net speed would become the speed of the swimmer in still water plus the speed of the stream. So let us put it this way. This is A to C and this is the point B. So this shall be C to B. This is the distance covered in 5 minutes. This is the distance covered in 5 minutes. So time equals distance by speed, from which we get distance equals speed into time. So this distance AC that we're talking about here is 5 times upstream speed. So this shall actually become 5u. And we're dividing this by 60 because we want the speed in terms of kilometers per hour. So 5 here is the time, u here is the speed. So ST is what we have here on the right hand side. Now 5 and 60 they will get cancelled and give us 12 here. So the distance AC shall be equal to x minus y by 12. Now similarly BC, the distance covered while swimming downstream was for 5 minutes. So 5 by 60 we are taking here into D, which is the downstream speed. That is x plus y. So again 5 and 60 cancel here, gets us 12. So the distance BC can be written as x plus y by 12. Now it is already given that the distance between points A and B is 100 meters. So this distance here is given to us as 100 meters. And what we need to find out, the speed of the stream, that is y, is what we need to calculate here. Now we know that this distance AB, as we have it here, is equal to BC. From that, if we subtract AC, what we get left over with is BA. So AB here is BC minus AC. AC we have found out, BC we have found out. So as AB is 100 meters, to convert it into kilometers, we are dividing it by 1000 meters. And BC is x plus y by 12, which is given here. And AC is x minus y by 12, which is given here. So performing these calculations, this 12 here is the LCM, goes to the left hand side, gets multiplied with 0.1 to give us 1.2, and x plus y minus x minus y, x is outside, so here x will cancel and we will be left with only 2y. The value of y comes out to be 0.6 kilometers per hour. Now that is given to us in choice D, which becomes the answer. A person covers 1 kilometer upstream in 10 minutes and the same distance downstream in 4 minutes. Now the distance is same. What will be the speed of the stream? It's the value of y you need to find out. Now we know that the upstream speed here has to be distance covered by time taken, and the distance covered here is 1 kilometer and time taken here is 10 minutes. Let us convert this into hours. So this shall become 10 by 60. 6 goes up, so it should be 6 kilometers per hour. Now downstream speed again is distance covered by time taken. Distance covered is the same, so that is 1, and time taken is 4 minutes. So 4 by 60 we will take because we need to convert it into hours. So 4 and 60 they get cut by 15, goes up, it becomes 15 kilometers per hour. So we have the value of u, we have the value of d. So only thing that we need to do is employ the formula, that is d minus u by 2, to get the value for y, which becomes 15 minus 6 by 2, that is 9 by 2, that is equal to 4.5 kilometers per hour. Now in the choices, 4.5 kilometers per hour is given in choice A. That becomes the answer. So a boat covers 1 kilometer in 7.5 minutes while traveling downstream. So what will be the downstream speed for the boat? That is distance by time. So 7.5 by 60 you can take, or you can also write it by 1 by 75 by 600. That becomes 1 by 1 by 8, goes up, works out to be 8 kilometers per hour. And then covers 5 kilometers in 1 hour by traveling upstream. So upstream anyhow is 5 kilometers in 1 hour. So it is 5 kilometers per hour. What will be the speed of the boat in still water? That is the value of x that we need to find out here. So now downstream speed we have, upstream speed we have. So you just need to employ the formula, that is x equals d plus u by 2 to get the value for x, that is 8 plus 5 by 2, which is 13 by 2. So that shall be equal to 6.5 kilometers per hour, which is given to us in choice B. That becomes the answer. In comparison to traveling some distance upstream, a boat takes half the time traveling the same distance downstream. Now what will be the ratio between the speed of the boat in still water and the speed of the stream? So x is to y is what you need to find out, and what is given to you here is that the time taken to travel upstream is double the time taken to travel downstream. Or the other way around, the time taken to travel a particular distance downstream is half the time taken to travel the same distance upstream. So time we know is distance by speed. So time taken to travel upstream is going to be twice that of time taken to travel downstream. So time taken to travel upstream is, let us say, some distance divided by upstream speed, x minus y, which shall be equal to 2 into this same distance by the speed downstream, which is x plus y. So when we take this and just put in the values, this distance happens to be the same, so it gets cancelled. So we are left with x plus y equals 2x minus 2y. This 2 gets multiplied here. So resolving this, x is equal to 3y. X is equal to 3y, so x by y is 3 by 1. So hence, the ratio between x and y works out to be 3:1. Now when we look at the choices, 3:1 is given to us in choice D, which becomes the final answer. Now, a man travels by a boat 36 kilometers upstream and 48 kilometers downstream and took 6 hours each time. What was the speed of the stream? So upstream speed shall be distance. So y is what we need to calculate. First of all, time taken to travel upstream is distance by speed. Speed upstream is u, which is x minus y. Now time taken to travel downstream is distance traveled downstream by speed downstream, that is 48 by x plus y. Now each time this is 6 hours. So 6 into 6 is 36 and 6 into 8 is 48. So we know x minus y equals 6 and x plus y equals 8. So now we have these two equations with us. So hence by resolving these equations for y, because we need the speed of the stream, we use subtraction here. So what we get here is minus 2y equals minus 2, which means y equals 1 kilometer per hour. And looking at the choices, 1 kilometer per hour is given to us in choice B. That becomes the answer. Now, a man covers 12 kilometers upstream in 5 hours. So speed we know is distance by time. So by that, upstream speed is 12 kilometers by 5. Now where the speed of the stream is 4 kilometer per hour. Now we also know that x minus y, because upstream here is x minus y, that equals 12 by 5. The value of y is given to us, that is 4 kilometers per hour. Now the value of x here shall be 12 by 5 plus 4. The value of y is 4 kilometers per hour given to us here. So it shall become 12 plus 20 by 5, that is 32 by 5. Now that we have found out the value of x here as 32 by 5, time taken to travel downstream shall be the distance covered, which is 15 kilometers, by the speed downstream, which is x plus y. So it shall become 15 by 32 by 5 plus 4. That is 15 by 52 by 5. It should be equal to, 5 goes up, 75 by 52. So this is what we get here, 75 by 52, which is equal to 123 by 52. And 23 by 52 into 60 if you do, because you need to convert this into minutes, because the choices are given to you in hours and minutes. So this becomes 23 by 52 into 60, both go by 4. So this is equal to 345 by 13. On dividing this, we get 1 hour 26, 7 by 13 minutes. Now this is given to us here in choice D, which becomes the correct answer. Now a motorboat covers some distance downstream. How much? It is not given to us. In 3 hours, and covers the same distance upstream in 3.5 hours. If the speed of the stream is 1.5 kilometer per hour, that is the value of y is given to us as 1.5 kilometer per hour, then what will be the speed of the boat in still water? What is it that we need to find out? We need to calculate the value for x. So speed downstream, you know, is x plus y. The distance is same. Distance is speed into time. So we can say that downstream speed into time taken to travel downstream is equal to upstream speed into time taken to travel upstream. That is nothing but the distance. So time taken to travel downstream is 3 hours. So it is 3 times x plus y, which is equal to time taken to travel upstream is 3.5. So it is 3.5 times x minus y. Now the value for y is already known to us, and that is 1.5 kilometer per hour. So 3x plus this y here is 1.5. So 3 into 1.5 should give us a 4.5 equals 3.5 into x is 3.5x minus the value for y here is 1.5. So 3.5 into 1.5 minus 5.25. This gets resolved here as 0.5x. This gets resolved here as 9.75. Directly double these two. Into 2 is x. So into 2 is 19.5. So we should get the value for x as 19.5 kilometers per hour, which is given to us here in choice C, becomes the answer. Now the speed of a boat while traveling downstream is 15 kilometers per hour, and the speed of the stream is 3 kilometers per hour. So downstream speed is given as 15 and speed of stream is given to you as 3. Now d is x plus y. So the value of x becomes 15 minus 3, that is 12 kilometers per hour. Now what will be the total time taken by the boat to cover 15 kilometers upstream and 15 kilometers downstream? These are your choices. So the value of x we have found out. Now the total time taken to travel 15 kilometers upstream and 15 kilometers downstream, very simple. So time taken to travel downstream is distance 15 kilometers by x plus y, that is the value of d, which is speed downstream, and time taken to travel upstream is distance 15 kilometers by x minus y. The value of speed upstream is x minus y. Resolving this, 15 by 15, 15 by 9, we add them. Obviously, this becomes 1. This becomes 5 by 3. So we get 2 by 3 hours as a total time to cover 15 kilometers upstream and 15 kilometers downstream. Now, 2 by 3 we are converting into minutes. Now, so 60 into 2 by 3 equals 40 minutes. So the total time in hours and minutes shall be 2 hours and 40 minutes, which is given to us in choice A. That becomes the answer. The speed of flow of water in a river is 4 kilometers per hour. So the value of y, as we see, is given to us. The length and width of the river is 8 meters and 4 meters. So length and breadth are given to us here. Then how much water will enter into the sea in 15 minutes? We're talking about the volume of water. And the time which is given to us here is 15 minutes in which the river water will flow into the sea. Now the amount of water flowing in 15 minutes shall be 4,000 by 4, that is 1,000 meters, because the flow of water in the river is already given to us as 4 kilometers per hour. So in 60 minutes, 4,000 meters of water flows into the sea. So hence in 15 minutes, how much water will flow into the sea? So this is divided by 4. So this should also be divided by 4. 60 by 4 is 15. Hence 4,000 by 4 shall be 1,000 meters. That's what we got here. So volume of water entering into sea in 15 minutes shall be the length and the breadth and the amount of water which is flowing into the sea in 15 minutes. So it works out to be 32,000 meter cube. Now this is meters, this is meters, this is in meters. So the volume of water will always be in meter cube. And this 32,000 meter cube is given to us in choice D, which becomes the answer. So friends, you saw lots of questions of different varieties and different types. Now please practice and apply the basics to whatever question comes your way with any kind of difficulty level. We will meet again in the next discussion. Till then, I wish you all the best, stay safe, and thank you so much.